Okay, so now we're going to try to use our algebra skills to solve some of these problems that involve quadratics. Okay, so this one says the path of a basketball after it's thrown from a height of 1.5 meters above the ground is given by this equation where h is the height and d is the horizontal distance. So we have a height and we have a horizontal distance. Okay, and what we know is that 0 is there, so that's a height of 0 and a horizontal distance of 0. So it says that it starts at a height of 1.5, so we can assume that it starts at 1.5 meters. Okay, and then from there it gets thrown and it lands somewhere. We don't know where. Okay, and it follows this equation here. Okay, so here we go. How far will the ball travel horizontally when it hits the ground? So when it hits the ground, that means that on our graph, the height is going to be 0. We can think of this as the ground, right? So there's the ground there. And so it hits the ground right there. Well, that looks to be like an x-intercept, and the height is 0. So we can go ahead and say that when it hits the ground, the h is 0. So now I'm going to use this equation. H is negative 0.25 d squared plus 2d plus 1.5. But I'm going to say h is 0. So I'm just going to replace that with 0. Okay, so now how do we solve that? Well, we remember that if I have a quadratic equal to 0, then I can use that quadratic formula. Right? D, in this case, not x, is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Right? And we can see right here that that's a, that's b, and that's c. Okay, so now I just go ahead and I sub everything in. So d is actually equal to negative b. Well, b is 2, so negative 2 plus or minus the square root of b squared minus 4 times a times c. And it's all divided by 2a. Okay, and now we just start working it out, just like we did. So d is equal to negative 2. Remember, our first job is to figure out what's inside the square root. So negative 2 plus or minus the square root of, if you put that into your calculator, you should get 5.5 divided by negative 0.5. Okay, now our next job can be to actually calculate the square root. So that's negative 2 plus or minus, root 5.5 is 2.35 divided by negative 0.5. Okay, and then what we're going to do, same thing that we always do at this point, is we're going to split our answer. And so we get one answer that's negative 2 plus, and sorry, that shouldn't be x1, it should be d1, is negative 2 plus 2.35 over negative 0.5. And the other answer is negative 2 minus 2.35 divided by negative 0.5. Okay, and now we just have to work these two answers out. And if you put these into your calculator, remember we have to keep brackets here. You will get the answer negative 0.7, and you'll get the answer 8.7. Okay, so what does this mean? So this negative 0.7, well, that's a d-value that's somewhere over here, right? If I continue this, that's where it would be. But that doesn't actually matter because the ball actually gets thrown right here, right? Like if I'm standing here, That's where the ball got thrown, right? So that means that the only answer that actually makes sense is this positive one, 8.7 meters. So that's our answer, and this one we don't count. So how far was the travel horizontally when it hits the ground? 8.7 meters. Okay? All right, let's look at the second bit. How high is the ball when it's 2 meters horizontally from the start? So in this case, if we look at our little graph that we made, right? So now we know that this is 8.7, this is 1.5. And so now the question is 2 meters horizontally from the start. So that means 2 meters this way. What's the height? Well, I know that d is 2, and the equation that represents this whole thing is h is equal to negative 0.25 d squared plus 2d plus 1.5. Well, if I know that d is equal to 2, I'm just going to sub that in. So negative 0.25 d squared plus 2d plus 1.5. And if you work that out, you get the answer of 4.5. So that means that this height right here is a height of 4.5 meters. So notice that if we know the y value, the h, it's a much harder problem. If we know the x value, we just sub it in and we find y. Okay? All right, now we want to know the maximum that the ball reaches. Well, the maximum is going to be right there, right? Like that's the vertex. Well, I don't know from the equation what the vertex is, but I do know that it lies on this axis of symmetry, right? And luckily, we found the two x-intercepts in that last problem. They're right here, negative 0.7 and 8.7. So remember that we find the AOS. So d is going to be equal to d1 plus d2 over 2. We add the two x-intercepts together and divide them by 2. So negative 0.7 plus 8.7 divided by 2. And when we work that out, we get 4. So that means that this is 4 meters. So now I want to know what's the actual height at 4 meters. Well, that means the height is negative 0.25 d, which in this case is 4 squared, plus 2d, and d is 4, plus 1.5. We work all that out, and we get a height of 5.5 meters. So that means that the axis of symmetry, the vertex is at 4, 5.5. And that's the max height. Right? So you see how this problem's all starting to put together everything that we've done in quadratics. Okay? Let's see what else we could ask. So what's the horizontal distance? Horizontal distance. So we're looking for d when the ball is as a height of 3. Well, I'm just going to use my equation. H is equal to negative 0.25 d squared plus 2d plus 1.5. And I look and, I know what h is. So I'm going to sub in 3 is equal to negative 0.25 d squared plus 2d plus 1.5. So I'm thinking, okay, I need to know the x value, which means I need the quadratic formula, but I don't have 0 on this side. So what do you think we do? Well, we make it so we have 0. We subtract 3 from both sides. And so now we're going to have 0 is negative 0.25 d squared plus 2d plus 1.5 minus 3, so minus 1.5. And then here we use the quadratic formula. Okay, I won't do that part for you, but yeah, that's just how that works. How high is the ball when it first gets thrown? So when it first gets thrown, I'm thinking of my graph. When it first gets thrown, it's right here, right? So actually in my problem, it says that it starts at a height of 1.5. But even if it didn't say that, when it first gets thrown, what I know is that the horizontal distance is equal to 0. So if I look at my equation, negative 0.25d squared plus 2d plus 1.5, I'm going to say, oh, d is equal to 0. I'll sub that in, and I get negative 0.25 times 0, that's 0, plus 2 times 0, that's 0, plus 1.5. So the starting height is 1.5. Okay? That's that. Okay? And then the last thing that I'll say is what's the horizontal distance when it's at a height of 4.5? So we know h is 4.5. I'll let you do this, but basically we say the height is 4.5. And now I have to subtract 4.5 just like we did. And then we're going to use quadratic formula on this. And the reason why that's different is when you finish up, you're going to get two answers that are both valid. Okay? Well, that's because, remember we said that the highest height is 5.5? So it'll hit 4.5 somewhere on the way up, and then it'll hit 4.5 somewhere again on the way down, right? So it's okay to get two answers as long as we can interpret those. All right? Okay, so your job is now to practice putting all that to the test, and you can watch this video as many times as you need to.